Welcome back to The Explainer. Today, we're going to talk about the invisible thread that connects a Mars rover to the app you just used to order lunch. It's all about the art of building for scale, making sure that really complex systems don't just work, but actually thrive under pressure. So let's kick things off with this really powerful idea, straight from the NASA playbook. Now, the keywords to focus on here are operable system and opposed constraints. In plain English, that just means building something that actually works while you're juggling a bunch of competing demands, like it has to be cheap and fast and safe all at the exact same time. Okay, I know what you're thinking, a rocket and the apps on my phone. It might seem like a giant leap, but honestly, the fundamental challenge is exactly the same. Whether you're sending astronauts to the moon or streaming video to millions of people, you are fighting a constant battle against one single thing: complexity. You see, at the very heart of both rocket science and software development is this discipline that's all about making smart, intentional trade-offs. It's not really about finding a perfect solution because, let's be real, that almost never exists. It's about finding the best possible solution given all the constraints. Think of a systems engineer as the conductor of an orchestra, right? Their entire job is to make sure the violins don't completely drown out the cellos. They have that big picture view, and it's what stops one part of a project, say a super fast engine, from succeeding at the expense of the entire mission, like, the fuel budget or the safety of the crew. So how does this whole balancing act actually play out in the digital world? Well, let's take a look at a classic problem that pretty much every software team has to face: choosing the right foundation for their application. This choice of architecture, it's a perfect example of what engineers call a trade study. You have to really weigh the pros and cons of different approaches, because the path you choose right at the beginning is going to dictate how your application handles success, growth, and change for years and years to come. The two main ways to go are what we call monolithic and microservices. A monolithic is kind of like a big, self-contained building, where everything is under one roof. A microservices architecture, on the other hand, is more like a campus of smaller, specialized buildings. Each one handles a specific job, but they all work together. And here's where it gets really interesting: how they handle growth. If a monolithic app gets a ton more users, you have to copy the entire massive application. It's really heavy on resources. But with microservices, if your user login service is getting hammered, you just add more copies of that one service. It's surgical, it's efficient, and it's literally built to scale. So, okay, let's say you've picked a scalable architecture. Now what? What are the actual tools an engineer pulls out of their toolkit to make it happen? How do you actually handle that sudden flood of new users when it comes? Well, the core strategy is called horizontal scaling. And honestly, the idea is wonderfully simple. Instead of trying to build one giant, super powerful machine to do all the work, you just add more standard-sized machines to your fleet. Think more boats, not a bigger boat. Engineers have a few really clever techniques to do this. And while stuff like read replicas are super helpful, we're going to focus on two of the most powerful strategies out there: caching and database sharding. First up, caching. Imagine your database is like a giant library. It holds everything, but finding a specific book can take some time. A cache is like putting the most popular, most requested books on a ready-to-go shelf right by the front door. It stores that frequently accessed data in super fast memory, so the system doesn't have to go all the way back to the library every single time. And this diagram here illustrates database sharding, which is just brilliant. If your one library gets so massive that it becomes slow and unwieldy, what do? Well, sharding is like breaking that one library into a whole network of smaller, specialized neighborhood branches. Now the system can read and write data in parallel across all these shards, making everything drastically faster. But here's the secret: having a toolkit of cool tricks isn't enough. The real magic, the real lesson from rocket science, is knowing when and why to use each tool. And that requires a formal, disciplined process. See, picking a tool like caching isn't just a gut feeling. It's the result of a rigorous process of design, analysis, and critical reviews. Let's just zoom back out for a second and see how this framework makes sure you're making the right choices right from the very beginning. Now, this is really interesting. This number comes directly from NASA's own analysis. A staggering 75% of a project's total lifecycle costs are locked in by decisions made during the early design phase. Just let that sink in for a minute. And that is exactly why NASA follows such a strict project lifecycle. By breaking a project into these phases, from early concept studies all the way to final operations, and holding these critical reviews at each gate, they basically force problems to the surface early, when fixing them is just a simple edit, not a billion-dollar catastrophe. Okay, so all of this, the trade-offs, the tools, the process, it all leads to the single most important lesson from systems engineering, and it's one that applies to both rockets and apps. So here's the crucial point. Getting the design right means your code works and your rocket flies straight. Okay, that's the minimum. But getting the right design means you built something that actually solves the real problem and meets the true goals of the whole mission. And this is really the enduring lesson here. True success doesn't come from just picking the trendiest tool or the newest framework. It comes from a disciplined process and a mindset that relentlessly asks, are we building the right thing? In the end, the process you follow is far more important than any single product you choose. And we'll just leave you with that thought. Perhaps the invisible architecture, the architecture of thought, process, and disciplined trade-offs, is the real foundation that's holding our complex modern world together.